In this video, we're going to go through a pretty common proof by contradiction question, and I'm going to show you a two-step format that you should use on pretty much 95% of questions. So step number one is you always assume the opposite of the statement is true. In this statement, it says there exists no integers x and y for which this equation is true. So what we're going to assume is that there does exist integers x and y, such that 6x plus 9y is equal to 1. Now we have to somehow disprove the assumption. Now, I always tell my students there's two ways to disprove an assumption. You either factorize both sides of an expression or you square both sides of an expression, depending on what makes sense in the scenario. In this case, we are able to factorize the left-hand side, so let's do that. I said both sides, by the way. It can just be one side in some questions like this one. So 3 goes into both of these terms, so you can factor out 3. And then inside the bracket would be 2x plus 3y. Close brackets, all of that is equal to 1. You can then divide both sides by 3 to get 2x plus 3y is equal to a third. And if we think about it now, we've assumed that x and y are integers. So if x is an integer, by the way, integer, all it means is just a whole number. It can be positive 2, negative 2, it can be 0. If we have x as an integer, 2x, 2 multiplied by any whole number, let's think about it. 2 times 4 is 8, it's another whole number. 2 times minus 3 is minus 6, that's a whole number. So 2x would be an integer if x is an integer. Now 3y would also apply that same scenario. 3 times any integer would also be an integer. Two integers, when you add them together, they'll add together to give you an integer. However, what we see here is that we have a third, which is a fraction. Well, integers can be fractions, like 6 over 2, that's equal to 3. But this is not an integer. So that's how you can disprove this particular contradiction. So it's either one is true or the other is true. If this one here, this contradiction is false, then that means that the original statement has to hold true. So as your final statement, you can say, since what we just found contradicts the assumption, sorry, I'll make it larger, the original statement must hold true. Or if you want to sound fancy, you can say the original conjecture must hold true. I'm just going to very quickly enlarge this. And did I make any spelling mistakes? No? Okay, perfect. And that's everything that you want to mention with these questions. So essentially, you're assuming the opposite of the statement is true. You're then using that contradiction to disprove the contradiction so that the original statement is true. Thanks for watching. Hope the video helped. Be sure to like and subscribe if it did. And yeah, let me know if there's any videos you'd like me to make about in the near future. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.